Good morning everyone. Myself Hemraj. I am your engineering mathematics audio navigator. In today's subtopic we are going to see about complex variables. Coming to the mark contribution of this particular subtopic, generally on an average 2 to 3 marks will be asked in this particular subtopic. And coming to the toughness of this particular subtopic, it is an easy topic and questions will be asked with respect to a particular region in this subtopic, so that if the student focuses on that particular topics or the chapter, then the students can all fill 3 marks in this particular subtopic. So spend some quality time to study complex variables so that all 3 marks will be guaranteedly taken by you. With this brief introduction of complex variables, let's get into the actual topics. Let me take you through one by one. Generally, the questions will be focused or heavily concentrated on majorly on 2 areas, which is Cauchy residual theorem and Cauchy integral equations and theorems. But generally 2 marks will definitely come from these 2 portions. That's why I said it is focused on a particular region, and these are those 2 regions. But having said that, the other 1 mark will make you differentiable from the other GATE competitors. I will tell you what do I mean by this. Generally everyone will focus on the Cauchy integral theorem and Cauchy residual theorem and their application to calculate the integrations and find out the residuals and things like that. So people generally study that and they get good marks, and I expect you also to do that. But the other 1 mark, which is the differentiator, which means that there are a lot of concepts involved in this complex variables in terms of analytical function. How does that means, what is single valued function, what is multi-valued functions, and things like that. So be very clear about all those things. That will help you to score the other 1 mark, which is essentially very important. Generally students fail to score that 1 mark. If you score that 1 mark, and that 1 mark will make you differentiable from other competitors. So I will take you through all the basics and the definitions of the complex variables, which will contribute for that particular 1 mark and which is going to be your differentiator. And we will also go through the mark concentrated region called residual theorem and the integral theorem as well. Yeah. With this introduction, let's move ahead with the definition of what is a complex number. If x and y are real numbers and then z is equal to x plus iy, it's called a complex number, and the real part of the z is denoted by re of z or r of z, and the y is called the imaginary part of the z. And with this definition of complex number, there is something associated with this: how to visualize or how to plot this particular number in a space, so which is called Argand plane or an Argand diagram. So if a complex number is given, be very familiar with that. How do I draw my Argand diagram if a complex number z is given? Generally people ignore this, but please don't ignore this. Questions can be asked from this. Might be a differentiator. So be very familiar with the Argand diagram and Argand plane, and how to draw a Argand diagram if a complex number is given, and what is the x and y, how do I denote that x and y, how can I convert that x and y into a polar form which is called r and theta. That's why Argand diagram will help you to visualize the complex number. So be familiar with that. With this, let us move on to the polar coordinates of a complex number. If z is given as x plus iy, which can very well be written as x plus iy is equal to r of cos theta plus I sin theta, or which can be shortly denoted as r e power I theta. And r of cos theta plus I sin theta is called the modulus amplitude form or polar form of Z. Moving ahead, let's move into the functions of a complex variable. So there are two main functions of a complex variable. You should be very much aware about the what is the definition of that functions of a complex variable, as well as when a function is given, you should be able to find out whether this function belongs to which form. Say for example, if z is expressed in the form of u and v, are the functions of r and theta, for every value of z there corresponds to a unique value of w, then w is called a single valued function of z, which is z is your complex number. For example, if w is equal to z square and w is equal to 1 by z are the single valued functions of z. Similarly, for every value of z there corresponds more than one value of w, then w is called multiple valued function of z. For example, w is equal to z power 1 by 4 is an example for multiple valued function. So be familiar with the definition as well as an example, because generally questions will be asked in such a way that they will give you a function and they will ask whether it is a single valued function or a multiple valued function. So you should be very much familiar about it. Moving ahead, there are two major definitions which is associated with the complex functions, which is like continuity of f of z and the derivative of f of z. Let's see step by step. Questions cannot be asked directly with these definitions, but the forthcoming applications what we use, the theorems and all, which is heavily depend on the limitations and the assumptions, will say that it has to be an analytical function, so that you should be aware of that when a function will be qualified as an analytical function. For that you should be knowing all these basic forms, which helps you to understand whether you can use this theorem or not, because sometimes questions can be also asked in such a way that whether this function is a analytical function or not. For that you should be knowing this. Yeah, with this brief introduction of analytical function, let's get into the definition of continuity of f of x and derivative of f of x. A single valued function f of z is said to be continuous at a point z naught if limit z tends to z naught, f of z is equal to f of z0. Similarly, derivative of f of z is nothing but a single valued function f of z is said to be differentiable at a point z naught if limit del z tends to 0, f of z naught plus del z minus f of z naught divided by del z exists. This limit is called the derivative of f of z at z naught and is denoted as f dash of z naught. So be very familiar with this definitions of continuity of f of z and derivative of f of z, where z is your complex number which is equal to x plus iy. Coming to the analytical function, you should be very much familiar with this function, because generally questions will be asked like analytical function, whether it qualifies or not, and what is the criteria to be an analytical function. Let's see what is an analytical function first, then what are the conditions for a function to be qualified as an analytical function. A single valued function f of z is said to be analytic at a point z naught if it possesses a derivative at z naught and at every point in some neighborhood of Z0. Similarly, a function f of s said to be analytic in a region R of a set plane if it is analytic at every point of R. So this is the definition of analytic function. So derivative of a function is heavily involved in the definition of the analytical function. So which is the key thing you have to take away from this definition. On top of that, there are other names for analytical function which is called a regular function or holomorphic function. So be familiar with the other names or the nomenclature of the analytical function as well. Now moving ahead, how would I prove whether a function is an analytical function mathematically, or how would I check whether a function is an analytical function mathematically or not with the definition given above, which we told a couple of minutes back. So the very famous equation will help us to identify whether the function is an analytical function or not, which is Cauchy-Riemann's equation. So don't get into the proof of the Cauchy-Riemann's equation, which is not required for the gate preparation, which is required only for your understanding. So for gate preparation they will not ask, but you should use Cauchy-Riemann's equation to find out whether the function is analytic or not. So apply Cauchy-Riemann's equation. Don't try to study the proof, or if you are really interested you can study, but that is not important for gate. And the Cauchy-Riemann equation says that a function is analytic when dou u by dou x equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x at every point in R, given that function is in a form that f of z is equal to u of x comma y plus I v of x comma y. Please note that the same Cauchy-Riemann equation is available for polar coordinates as well. Whatever I have told you, dou u by dou x equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x is in Cartesian form. A similar formation is available in polar coordinates as well. So be very familiar with the Cauchy-Riemann equation in polar coordinates also, because questions will be very heavily asked in that. They will give you a function, either you have to convert Cartesian form into coordinate polar form, or you have to convert back polar coordinate into a Cartesian coordinates. Then you have to find out whether it is a analytical function or not. For that you should be knowing the criteria in both the forms. So for example, in polar coordinates the f of x will be given as u of r comma theta plus iv of r comma theta, and which will be analytical in the region R if dou u by dou r equal to 1 by r dou v by dou theta and dou v by dou r equal to minus 1 by r dou u by dou theta at every point in that region. So be very much familiarized with this two forms of Cauchy-Riemann's equation, basically polar and Cartesian forms, and try to solve a lot of problems using this equation, which is very easy generally, and get yourself familiarized and by heart with these equations. Don't try to learn these proofs, which is not going to help in any way. With this, let's move ahead into some of the standard results of analytical function, which will help you to score marks directly without trying to work out in the gate exam hall, which might be a time taking process as well as a error prone process. So let me take you through a couple of standard results which generally will be asked in the question. So let me read the line. The analytical function with the constant real part is a constant, and a constant modulus analytical function is also a constant. So there are two standard results involved inside it. Whenever you say an analytical function with the constant real part, then the analytical function itself is a constant, as well as whenever an analytical function has a constant modulus, then also analytical function is a constant function. So these are a couple of standard results, and the proofs are also available, which is very easy. Only using Cauchy-Riemann's equation you can finally take it out. But the thing is, you don't spend time for these proofs in the exam hall, which may take long time, as well as an error prone thing. If you know this upfront, you can directly apply this equations and you can these results, and you can get scored very easily. This makes you different from other competitors. With this, I would like you to get little more familiarized with the properties of analytical function. Lot of questions will be asked with respect to the properties of analytical function, which are basically very easy to answer, and there are not many properties as well. Some 3 or 4 properties are there. So get yourself very much familiarized with these properties of analytical functions, so that you can score easy marks. So this is the place where you can score easily marks. The property 1 is the real and imaginary parts of an analytical function w is equal to u plus iv satisfy the Laplace equation in 2 dimension. That is, del square u is equal to 0 and del square v is equal to 0. The proof for this can be derived from Cauchy-Riemann equation, which is just a 2-step proof. If you want, you can go through, but be very much familiar with the result of the property. And there are some important things that you need to note along with this property. So you should keep an eye not just for the property results, but what is the byproduct of these properties, because questions can be asked with respect to the byproducts also, because everyone will generally focus on the general property, but there are some byproducts associated with this property. For example, a real function of two real variables x and y that possess continuous second order partial derivatives that satisfies Laplace equation is called a harmonic function. So whenever an analytical function which is having a real variables x and y, which are continuously possessing second order partial derivatives and also satisfying Laplace equation, then those equation is called, or those function is called harmonic function. So keep those in mind. If u and v are harmonic functions such that u plus iv is analytic, then each is called the conjugate harmonic function of the other. So these kind of byproducts you should keep in your mind. Similarly, the real and imaginary property 2 is nothing but the real and imaginary part of an analytical function w is equal to u of r comma theta plus iv of r comma theta, which also satisfies the Laplace equation in polar coordinates as well. So be very familiar with that. And the third property is, if w is equal to u of x comma y plus iv of x comma y is an analytical function, the curves of the families of u of x comma y equal to a and the curves of the families of v of x comma y equal to b cut orthogonally. So be very much familiarized with this property, which means that they cut orthogonally, means their slopes will be, the product of their slopes will be -1, which can also be proved using Cauchy-Riemann's equation. So be very familiarized with that. Generally how the questions will ask is, so they are orthogonal, then what are the constants? So you have to find the slope, which is as usual, and you have to multiply that and equate it to -1 and find out what is the constants a and b. Questions will be very frequently asked in such a form. So be familiar with this. And the property 4 is if w is equal to u of r comma theta plus iv of r comma theta is an analytical function, the curves of the families of u of r comma theta equal to a cut orthogonally the curves of the family v of r comma theta equal to b, where a and b are arbitrary constant. It is the same property as the third property, but only thing it says is even in polar coordinates that holds true. Now with this, there is an important thing called construction of an analytic function when its real or imaginary part is known. Sometimes questions can be asked in this particular topic. How will it work out is they will give you the imaginary part of a particular analytical function and they will ask you to construct the analytical function, or they will give you the real part and they will ask you to construct the analytical function. So there are two methods to do it. So one method is very straightforward, since you know the Cauchy-Riemann's equation, what is equal to what. For example, dou u by dou x equal to dou u by. So you find out those things and you use the ordinary differential equation variable separable method and just integrate it. You will get the analytical function. So which is the very straightforward method. Use the Cauchy-Riemann's thing and get the answer, and be very familiar with the working principle of that. Don't take it for granted. So you have to try and be very familiar with the working principles of that. The second is this little important. What is that is Mellin-Thomson method. So there are two methods you can construct. The second method is Mellin-Thomson method. So where there is a direct formula involved in it, memorize those formula and get yourself very much familiarized. Do practice quite a few problems with respect to Mellin-Thomson method so that you can score full marks in that. Let me iterate on the formula. F of z equal to integral ux of z comma 0 minus I uy of z comma 0 dz plus c, where c is an imaginary constant of integration. With this, we will move ahead with the integrations using the complex variables or complex functions, which might be little important for you all, because till now whatever we have seen is for that one mark that will differentiate you from others. Now this is the part where questions will be asked for sure, and you have to be very much thorough and familiar with this part so that you can score the other 2 marks, which everyone will score this mark, and this is very easy to score. Only thing, there are 2-3 theorems and the formulas that you need to keep it in mind, and you need to know how it has come, and just practice those things. You will get these 2 marks for sure. So with this thing, let me introduce something called complex integration. So these integration generally happens in such a way, simply and multi-connected regions. So be yourself very much familiar with the definition of what is a simply connected region, what is a multi-connected region. Get the definitions very clearly. So the very famous theorem called Cauchy integral theorem, or Cauchy's fundamental theorem it is called. Let me iterate on that theorem. Don't get into the proof of this theorem, which is not required for GATE at all, but the result of this theorem is heavily used. If f of z is analytic and its derivative f dash of z is continuous at all points on and inside a simply closed curve C, then integral C over C f of z dz equal to 0. Let me reiterate on it, which is very important. If f of z is analytic and its derivative f dash of z is continuous at all points on and inside a simple closed curve C, then C f of z dz equal to 0. You should be also little familiar with the some important points with respect to the theorem, or the I will iterate on that. For example, If f of x is analytic at all points on and inside a simply closed curve C, then integral C f of x dx equal to 0. We have proved Cauchy's integral theorem in a simply connected region. Similarly, be also be very aware that it can be proved for multiply connected regions also. What does that mean is, if an integration is asked in the Cauchy-Riemann's using Cauchy-Riemann's theorem, don't think that it can be only done for a simply connected region. It can be connected for multiple region also. Only thing, you have to split the integration and do the normal Cauchy-Riemann's Cauchy integral using the Cauchy integral formula. You have to do it, but you should be aware that I can also do using splitting the equation, which is basically the multiple connected region. So these kind of things you should be very much familiar, because generally students think that it can be done only for simple connected region, and once the connectivity breaks and it has a multiple connected region, people think that okay, there is something else. No, the Cauchy-Riemann theorem needs to be used there, Cauchy integral theorem needs to be used there, but the whole idea is you have to cut the limits and you have to get 2-3 integration and you have to sum it up. Okay, with this I will take you the Cauchy's integral formula. If f of z is analytic inside on a simple closed curve C that encloses a simply connected region R, and if A is any point in R, then f of A is equal to 1 by 2 pi I closed integral of C f of z divided by z minus A dz, where C is described in the anti-clockwise sense. So the key is f of A is equal to 1 by 2 pi I closed integral C f of z minus A dz. So similarly, you can also use the Cauchy integral formula to a doubly connected region. Only thing, you have to split the integration. Let me give you an example of that. If f of A is equal to 1 by 2 pi I closed integral C1 f of z divided by z minus A dz minus 1 by 2 pi I closed integral C2, which is the other region, f of z minus A dz. Don't get into the proofs of all those things, which is not going to help you, but these applications or these integration formulas will be used to calculate lot of integrations. The next thing is Cauchy's integral formula for derivatives of an analytical function. Till now we have seen f of A. What will happen if you want f dash of A? So f dash of A is equal to 1 factorial divided by 2 pi I integral C in a closed curve f of z divided by z minus A the whole square dz. And further, if you want the second derivative or third derivative, be very much familiar with the generalized derivative formula. For example, I will put this in such a way: f n of A, where n is your nth derivative, which is equal to n factorial 2 pi I closed integral C f of z divided by z minus A n plus 1 dz. So if you know the Cauchy's integral formula as well as Cauchy's integral formula for derivatives of an analytical function, generally questions will be asked from this, and definitely you will get 1 mark from this. An integration will be asked to calculate, and you know that you have to check whether it is an analytical function within the given interval or not. That you need to check using the Cauchy-Riemann's thing, or like using the continuity definition or the derivative definition within the given region R. Then you will come to know you need to find out a simply connected integral formula or a multiple connected integral formula. Once you do that, write the integral formula, then that f of A will be given to you. Then you find out the integration by just doing LHS equal to RHS and find out the values. So get very much familiarized with the working principles to how to calculate the integral. The idea is not to calculate f of a. F of a will be given to you in the question, but the idea is to calculate the integration using the Cauchy-Riemann's Cauchy integral theorem, which will make your life easy. With this, let's move ahead to an important topic called series involved in the complex variables. So there are three different power series involved in the complex variable. One is Taylor's series. Be very much aware of the statement of the theorem. Don't get into the proof. Let me repeat the statement, or let me iterate on the statement. F of z is equal to f of a plus f dash of a divided by 1 factorial z minus a plus f double dash of a divided by 2 factorial z minus a the whole square plus f triple dash of a divided by 3 factorial z minus a cube plus in it all the way goes to infinity. So this is the Taylor series for the analytical function. And similarly, get yourself very much familiarized with the Laurent series, which is nothing but f of z is equal to summation n is equal to 0 to infinity a n of z minus a the whole power n plus summation n is equal to 1 to infinity b suffix n into z minus a the whole power minus n. So be very much familiar with these results, and the statement of these results is very important. It is not just result. You should know that when these results can be applied, what is the assumptions and what is the limitation of this series, so that you can use those things in calculation of a particular problem. The third thing is like power series. So be yourself very much familiarized with the power series as well. And with this, I would like you to take you through a couple of more nomenclatures which will help you to get 1 mark if you are lucky. So there are different types of singularities. There are different types of classification of singularities, like isolated singularities. You be yourself what is an isolated singularities, get with the definition as well as the example of the isolated singularities, which is very very important. And do yourself note that what is a pole, what is called as a pole, and get the definition of pole and get an example of the pole. Similarly, there are a lot of other singularities like essential singularities, removable singularities. Get yourself familiarized with the definition of those singularities as well as the example of those singularities. We have come to the last part of the complex variables, and which is very important part, where you will get 1 mark for sure, which is residues and evaluation of residues. If a is an isolated singularity and any type for the function f of z, then the coefficient of 1 by z minus a in the Laurent series of f of z at a z is equal to a, valued in 0 greater than modulus of z minus a less than r1, is called the residue of f of z at z equal to a. So don't get very much frightened by this definition of residue of an analytical function, but what I would recommend is be yourself very much familiarized with formulas for the evaluation of residues. Residues is a place where you will get 1 mark for sure. Get yourself very much familiarized with the Cauchy residues theorem. I will iterate on that. Integral closed in the curve C, f of z dz is equal to 2 pi I r1 plus r2 plus all the way it extends to rn. So using this you can find out the integration, or if the residue is also asked, you can get the residues using the Cauchy residue theorems formulas as well. With this, I will also take you through the some of the form of the gate questions which can be asked using the complex variables. Generally, let me take you through an example. So they have given a function called f of z is equal to 1 minus 1, f of z is equal to 1 by 1 minus z square, and they have asked the coefficient of 1 by z minus 1 in the Lorentz series is do the expansion and get the coefficients, and the value of z is equal to 1, that is also given. So similarly they have given a 2-mark question in such a way that the value of the contour integral in closed integral cos h z divided by 4z square plus 1, so which is in the form of this, use the Cauchy integral theorem formula and get this value. And they have also given the mod integral modulus of z is equal to 1, so the value is also given, which is your f of a in the Cauchy integral formula. Use that and get the answer for that. And similarly there is a question called f of z is equal to u plus iv is an analytical function, and u minus v is equal to x minus y the whole cube plus k xy x minus y. Then k is called, what is the value? Use the properties of the analytical function, because they have already told this analytical function, and get the value of the constant k. And similarly, yeah, the next question is using the Cauchy integral theorem. They have given an integral in a closed loop of modulus z is equal to 2 e power 1 by 2 divided by z minus 1 the whole square dz. So use the Cauchy-Riemann integral theorem, but ensure that whether it is single connected or which is simply connected or multiple connected, then you make a call that whether should I go with a simple integration or a multiple integration, then you make a call on that. So these kind of questions will be asked. Okay, there is one more question with respect to residue as well. For example, they were directly asked the residue of a analytical function f of z is equal to sine 4z divided by z plus pi by 4 the whole cube at z is equal to minus pi by 4. So use the residue function directly, Cauchy residue theorem function directly, and get the answer for this. So these kind of questions will be asked, and you should score full marks in this particular topic. Only thing, you should focus on integral formula and the residual formula and Cauchy-Riemann's equation, so that you will get very good marks in this particular subtopic. But you have to practice a lot of problems, because you will see functions in different form. You should be in a position to convert those functions into the normal way of integration. That's the key behind this. Once you find out that, then it's very easy. You directly apply the formula and get the answer. With this, we are completing the complex variable subtopic. We will see another topic in the other audio. Thank you.